Hello guys, so now we are going to solve some questions from magnetostatics. See, before that I would like to tell one thing, the reason why I have started this channel. See, as far as any competitive exams like JEE or NEET, any type of entrance examinations for graduation, if you see, the main thing is problem solving skills. So for that you need to practice some questions. Literally you can understand those questions solutions from any text solution or any video solutions, but you should ask yourself why you couldn't able to solve that question by yourself. There are many YouTube channels, many teachers and coaching institutes where they will be solving the questions, but only few teachers will be telling you the right approach, how to approach a particular question. As a student, I have also faced this problem, so that's why I have come up over here to tell you some tricks or the right approach, the way how you can actually crack a question. If you crack a question, definitely you can able to solve easily. So let's solve first this question. See, just a basic formula. If you see, this is the formula you have learned from moving charges and magnetism, as well as in EMI chapter. Flux is nothing but number of turns into magnetic field into area. If you see a rod with a circular cross section area, they have given length of the rod, they have given wound uniformly with 400 turns of an insulated wire. So a rod is being wounded by a wire. If a current of this ampere is flowing in the wire windings, if you have a rod, so wire is being wounded like this. So the total magnetic flux produced inside the windings, inside that windings, the magnetic flux will be produced, right? So the value of the flux they have given. So relative permeability of the rod. So it looks like a solenoid, right? The whole system looks like a solenoid. So we know that if you have given it a number of turns magnetic field area, the flux formula is NBA. As well as for a single solenoid, this is the formula I have learned, mu naught times of NIA. There are derivations, but for competitive examinations, just direct formula is very important as far as your JEE means as well as NEET is concerned. So mu times of N time for a single solenoid, for n turns, 400 turns, you have to multiply that with capital N, which is nothing but number of turns, and they have asked relative permeability. So this mu is nothing but permeability of vacuum. So if you have placed this solenoid, the system, in a permeability medium, so you have to multiply that formula with mu r, which is nothing but the relative permeability which they are asking. So if you use this formula, you have this quantity that you can just derive, that you can get from this equation, where they have given number of turns, magnetic field, area they have given, number of turns, length they have given in centimeters, so I have converted it to meter. So after finding flux, you put over here, and n they have given mu n I a, everything they have given. Small n is nothing but number of turns per unit length. So every data they have given, mu r can't you find from this. So if you calculate mu r, that's nothing but your answer. So this year JEE means 2023 question. So next question, if you see, that's it, just a direct formula based question. Next question from moving charge and magnetism. See, two long current carrying conductors are placed parallel to each other at a distance of 8 cm between them. So these are the two conductors, distance between them given. The magnitude of the magnetic field produced at midpoint between the two conductors due to the current flowing to them is 300 micro Tesla. So equal current flowing, the value of current they are asking. See, if you have given with a conductor whose conductor, if they have given and current is flowing through that at a distance d, if they're asking magnetic field, which is an infinite wire conductor, so the value will be mu naught times of I divided by 2 pi d. This is the normal formula. So here if you see the direction, if you place your thumb finger, curl your four fingers, so that will point in inward direction. So due to this wire at this particular point, magnetic field will be inward, right? It will be inward. So if you place the thumb in this direction and curl your fingers, then you will see the magnetic field due to this wire at this particular point is also inward, right? So due to both these wires, the magnetic field at this particular point, let's say O point, is inward. So we can add these two value and we can equate this to the net magnetic field due to both these wires at particular point O. So that's why I have just added and I have multiplied by 2 because the current value they have given equal current. So we can equate it with B, nothing but magnetic field value due to this wire at this point. D distance they have given, so at midpoint D by 2, that's why D by 2 I have written. So every value if you substitute you can get the value of I. This is the direction I have written over here. See, if you place your thumb in the direction of current, curl your fingers, that will give you the direction of magnetic field. This you must have learned in the theory parts itself. So this is just a formula. Okay, with this formula you can just actually solve this question. So if you solve, you will be getting the answer in the same direction, option A, right? So next question, if you see, so this question seems to be a little lengthy in terms of complex calculation, but actually there is nothing, same type formula what we have used in previous question, only just direction you have to take care.